Hi everyone. Today we're going to study double integral with variable limits. We have two cases here. Case 1 is this: the definite integral from a to b. And the second integral has limits with variables. The lower limit is the function g of 1 of x, while the upper limit is g sub 2 of x. The function f of xy dy dx. Case 2 is here, the integral from c to d. And the second integral with variable limits. The lower limit is h sub 1 of y, and the upper limit is h sub 2 of y. The function f of xy dx dy. To evaluate each case, start by evaluating the inner integral, and the result is used as the function for the outer integral. Let us see example 1. Evaluate the integral from 0 to 1 and from 0 to 1 minus x. The function is y dy dx. Let's start by solving the inner integral. So we can write like this. Let us copy this inner integral on this side. Then let us evaluate with respect to y, which means we integrate the function with respect to y. We will take x as constant if ever there is x. So the integral of y is y squared over 2. And this would be evaluated from 0 to 1 minus x. Substituting the values, we have 1 minus x, this is squared, all over 2, minus 0 squared, all over 2. In the second fraction, because of the 0, this would all be equal to 0. So our answer here is the first group itself. This is the answer for the inner integral. Let us substitute this in our double integral here. So the simplified integral now is the definite integral from 0 to 1. The square of the quantity 1 minus x all over 2 dx. We can simplify further by moving the constant 2 outside, or we say 1/2 comes out, and it becomes like this. Now we are ready to do integration. By substitution, we let u equals 1 minus x. It follows that the integral here becomes 1/2 times the definite integral from 0 to 1. The function is u squared minus du. We can move the negative sign with a constant outside. So we have this negative 1/2, the definite integral from 0 to 1, u squared du. Then let us integrate. This negative 1/2 constant we will just copy times the integral of u squared is u cubed over 3. We simplify further by multiplying 2 by 3. Let us return the value of u, and that is the 1 minus x. So we have now negative the cube of 1 minus x all over 6. And this would be evaluated from 0 to 1. Substituting the values, we have now the first group, negative 1 minus 1, and this is raised to 3 all over 6, minus the second group, negative 1 minus 0. The quantity is raised to 3 all over 6. Look at the first group. This 1 minus 1 becomes 0, 0 cubed is 0, and the 0 over 6 will just be 0. So the first group will just be 0. Let us simplify the second group. Negative and negative becomes positive. 1 minus 0 is 1, and 1 cubed is simply 1. So we have this 1 over 6. This is the final answer. Example 2. Evaluate the double integral. The first integral from 0 to 2. The second integral from 0 to 2 minus y. The function is the square of x plus y. dx, dy. Let us solve starting with the inner integral. So we can write like this. Then let us copy the inner integral on the side. Let us integrate this with respect to x. It means we will integrate with respect to x, and that is, we will take y as constant. By substitution, we let u equals x plus y. It follows that the definite integral from 0 up to 2 minus y, here the function now becomes u squared du. Evaluating this, we have u cubed over 3. Let us return the value of u as x plus y. So we have the cube of the quantity x plus y all over 3 to be evaluated from 0 up to 2 minus y. Substituting the values, we have now the first group 2 minus y, then plus y, all raised to power 3, all over 3, minus the second group 0 plus y. This is raised to power 3 all over 3. In the first group, we have negative y and y. That becomes 0. Only the number 2 remains in the numerator. And this is raised to 3. So that would be 8 over 3. Then minus, in the second group, this will simplify into y cubed over 3. In here, we can see that we have like fractions, so we can combine the numerators. Simplifying this, we can write 8 minus y cubed all over 3. This is the answer for the inner integral. So we can substitute this in the double integral here. So our problem now is simplified into the definite integral from 0 to 2. Our function now is 8 minus y cubed all over 3, then dy. We can simplify this by moving this denominator 3 outside the integral sign. So we have now like this. Then let us proceed with the integration. This constant 1/3 we will copy. Integral of 8 is 8y minus integral of y cubed is y power 4 all over 4. Then let us evaluate this from 0 to 2. Substituting the values, we have the 1/3, and the first group is 8 times 2 minus 2 raised to 4 all over 4, minus the second group, 8 times 0 minus 0 raised to 4 all over 4. Look at the second group. Because of the 0, all of this will be 0. Then let us simplify the first group. 8 times 2 is 16, minus 2 raised to 4 is 16, divide by 4 is 4. 16 minus 4 is 12, and the 12 times 1/3 will give the answer 4. This is the final answer. I hope you learned something from this video. See you again next time.